Okay, welcome to lesson 3 on grade 12 sequences and series, and we're now going to look at geometric sequences. Right, unlike arithmetic sequences where we were adding a fixed amount, we are now going to be multiplying by a fixed amount to get from one term to the next. That fixed amount could be negative, and it also could be a fraction. So let's just look at some examples here. For example, this first one, 1, 2, 4, 8, our next term here would be 16, because we are multiplying by 2 in each case, and the next term would be 32 and then 64. Right, for this next one, we're actually multiplying by -3 to get from one term to the next. So the next term here would be negative 162. It would actually be positive 162. The next one would be negative. If we multiply this by -3, we're going to get negative 486. So here we are multiplying by -3. In this one, we are actually multiplying by 1/10, right? So the next one would be 0,01, and the next one would be 0,001. We're multiplying by 0,1 or 1/10. And in this last one, we're multiplying by -2x. So our next term would be positive 16x to the 5th. And the next one would be negative 32x to the 6th. So we're multiplying by -2x. Right, so there are two parameters which affect a geometric sequence. The starting number, exactly the same as an arithmetic sequence, the starting number, which we call A, and the common ratio, which we call R. Right, and R is found by taking any term and dividing by the term before it. So dividing it by the term before. So for example, R could be the 8th term divided by the 7th term. Or it could be the 20th term divided by the 19th term. Right, or more generally, it could be the nth term divided by the n minus first term, the one before the nth term. Right, so for now, we're going to go back to those three equations, and we're just going to establish that, in fact, R is what we were multiplying by in each case. In this one, R is 2, here R is -3, here R is a 10th, or 0,1, and here R is -2x. Okay. A really, really important idea is that if three numbers A, B, and C are in geometric sequence, then the second one divided by the first one will be exactly the same as the third one divided by the second one. In other words, B over A will be the same as C over B. We've put that in the box because it's a really, really important idea. If we know the two parameters A and R, then we are done. We can write down as many terms of any sequence as we like. Let's have a go. So let's write down the first 5 terms of these sequences. This one starts with -1, and then we're going to multiply by 3, so we'll get -3. Then we're going to multiply by 3 again, we'll get -9. Then by 3 again, we'll get -27. And then by 3 one more time to get -81. That's the first 5 terms of a sequence with those parameters. If A is 128 and R is -0.5, our first term is going to be 128. When we multiply that by -0.5, right, it's going to become -64. When we multiply -64 by -0.5, we're going to get +32. Then we're going to get -16, and then we're going to get +8. And those are the first 5 terms of that one. This one, A equals 2x and R equals x, 2x. The next term would be 2x squared. We're multiplying by x. Then 2x cubed. Then 2x to the 4. and then lastly 2x to the 5. Okay, so very, very straightforward. Now the formula that we have for the nth term of a geometric sequence is Tn equals AR to the n minus 1. What we're going to do is we're going to look at proving this, firstly with the general case, with a specific case, and then secondly with the general case. If we look at this geometric sequence here, T1 is 3. T2 is 3 times 2. Right? Just 1, 2. T3, we're going to take this one, the one before, and we're going to multiply by 2 again, right? We could write this obviously as 3 times 2 squared, right? T4, we're going to multiply the previous term by 2. So what ends up happening is we get 3 times 2 to the 3. 3 2's multiplying it. And so it carries on. And if we just think about it, T20, for example, would be 3 times 2 to the 19. We can see that this power is 1 less than the term number. 1 less than the term number. 1 less than the term number. So generally speaking, for this particular one, Tn would be 3 times n minus 1 2's multiplying together. In other words, 2 to the n minus 1. That was a sort of specific example. Now we're going to look at the sort of general case, all right? Our first term will be a. Our second term will be a times r. Our third term will be a times r, or ar squared. Our fourth term will clearly be a times r times r times r, which is ar cubed, and so on. So for example, maybe our 8th term would be a r to the 7, 1 less than the term number. Right, and importantly, our nth term will be a r 1 less than the term number. So this is the kind of the really important formula for a geometric sequence. It is really important that we now can deal with both types of sequence. So what we're going to look at now is we're going to classify some sequences, and we're going to have a look, and we're going to decide, are they arithmetic, or are they geometric, or are they in fact neither? This one over here is definitely geometric. All right, we are multiplying each time by 3, and that rule holds throughout. This one over here is in fact neither arithmetic nor geometric. If we take 5 minus 2, we get 3. 8 minus 5 is also 3. It's looking good. But 12 minus 8 is not 3. So it's not arithmetic. 5 divided by 2 is 2.5. 8 divided by 5 is not 2.5. So it's not geometric either. This one is neither. Right, the next one, we are subtracting 11. We're subtracting 11, we're subtracting 11. We're actually adding negative 11 in terms of our R value, our D value is negative 11. This one is definitely arithmetic. There's a fixed difference between any two terms. And then this last one is looking good for a geometric. 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2, 18 divided by 8 is not 2. Had this been 16, it would have been geometric, but in fact this one is neither. Right, you could make up some more examples in the space that exists at the bottom of the page there. Right, let's go now back to geometric sequences, and we're going to use our new formula, Tn equals AR to the n minus 1. And just as we did previously, if we are missing just one variable, then we should be able to kind of calculate any number of bits of information. So for example, this question says find the 8th term. So our formula is Tn equals AR to the n minus 1. We want T8, so that's going to be A, which is 2, R is 3. 6 divided by 2 is 3, 18 divided by 6 is 3, and we're finding T8, so it will be to the 8 minus 1. It will in fact be to the power of 7. Very, very important idea here, just in terms of some exponents. We do not multiply the 2 by the 3 and then raise to the power of 7. We raise 3 to the power of 7 and then multiply the answer of that by 2. And our final answer for the 8th term of this is 4374. And we'll see that geometric sequences can grow quite quickly. Right, let's have a look at this one. This one tells us some specific information. We know the common ratio, and we know that the 5th term is 1,5. Write down the first 3 terms. What we need to establish is, what is the first term? Right, what does this thing start with? Okay, so what we're going to do, we're going to write down our formula. Tn equals ar to the n minus 1. Then we are going to put this fact that the 5th term is 1,5. So 1,5 equals r is negative a half, and we're going to raise that to the power of 5 minus 1, or 4, right? Because that's the 5th term is 1,5. There's only one variable left here now, right? So what we're going to do is we're going to work out what negative a half to the power of 4 is, and it's actually 1/16. Now we've got 1.5 here. We're going to divide both sides by 1/16, and we get that a is 24. So our first 3 terms are going to be 24. Then we're going to multiply that by negative a half to get negative 12. Then we're going to multiply negative 12 by negative a half to get positive 6. And there are our first 3 terms of that sequence. Okay. Now we have another one. A sequence has T5 is 1,25 and A is 20. This time we need to find R. Right? Once again, we're going to write down our formula. Just good practice to do so. Right? 1,25 is going to be 20, that's A, times R to the 4. Right? When we divide this out, we're going to get 1,25 over 20 is R to the 4. And we end up getting, in fact, when we find the 4th root, we end up getting that R could equal a half, right? But because it's an even power, we can actually also have minus a half. Right, so there in fact are going to be 2 options here to write down the first 3 terms. If R is a half, then our first 3 terms are going to be 20. Half times 20 is 10. Half times 10, or 10 times a half, 5. Right. However, if R is minus a half, then our first 3 terms are going to be 20, negative 10, positive 5. So there are 2 possible solutions to that one. Okay. At the moment, we don't have the skills to solve for n in the exponent. The only way we're going to be able to do that is sort of by trial and error for now. A little bit later in our grade 12 year, we're going to learn a new function which will enable us to do that. Right, so this question is asking, how many terms are there in this sequence? Well, we know it's geometric, so let's write down our formula. And what we want to find out is this, what number term is this? All right, so we're going to put that there as a term, 729, and we're going to try and work out what is the value of n. A is 1, R is 3 to the n minus 1. Right, and now it becomes a sort of a bit of a trial and error thing on our calculator. If we experiment, we'll see that 3 to the 6 is 729, and that's the same as 3 to the n minus 1. So n minus 1 must be 6. We add 1 to both sides, we get that n equals 7. So the 7th term is 729, and there are 7 terms altogether. This next question says, is 8,194 a term in this sequence? All right, now remember the formula. And what we're going to do is we're going to put 8194 here. And we are then going to see, remember A is 2, we're going to see if we can find an R value. Sorry, R is in fact also 2. We're going to see if we can find an N value to make this thing work. When we divide both sides by 2 here, we get 4097. Is 2 to the N minus 1. Playing around with the calculator, we'll see that in fact 2 to the 13 is pretty close, but not exactly right. So in fact, we'll find that it's not actually possible to make 4097 exactly. So no, it's not a term. Remember, N has to be a whole number, a positive whole number bigger than 1. Right. Bigger than or equal to 1, sorry. Okay, let's look at this. And remember that if we've got consecutive terms, all right, then this one divided by this one, if they're in arithmetic progression, A divided by 3 must be the same as 48 divided by A. Okay, right, what we're going to do now, we're going to multiply both sides by A. So that leaves us with an A squared over here over 3 equals 48. And lastly, we're going to multiply both sides by 3. So we in fact get A squared equals 48 times 3. Right, now 48 times 3 is 144. Just want to make the point here that if we've got two fractions that are equal, the top of the one times the bottom of the other will always be equal to the bottom of the one times the top of the other. All right, and we can see that there, A squared equals 48 times 3. That would have been a more direct way of clearing out the fractions here. Okay, now we're going to square root both sides. Because it's an even power, remember that we can have A equals plus or minus 12. And we can see that there's two possible answers here. If A is 12, the sequence is going to look like this: 3, 12, 48. And that is definitely a geometric progression. We're multiplying by 4 in each term. Or A is minus 12, right? Sorry. If A is minus 12, we're going to get 3, negative 12, 48. Right. And this is also a geometric progression, but this time R is negative 4. With the purple one, R is positive 4. Question 7 is very similar, right? If these are consecutive terms of a geometric progression, then the second term divided by the first term must be the same as the third term divided by the second term. Okay, remember what I've just told you? The top of this one times the bottom of that one will be equal to the top of this one times the bottom of that one. Okay, so a quick way of clearing out these fractions: p plus 3 times by p plus 3 all squared, will be the same as 3p plus 5 multiplied by p plus 1. Right. Squaring a binomial, really important thing that we often do. Remember, we square the first factor, the first term there rather. Then we multiply these two things together and double, we get 6p. And then we square the second term and we get 9. Here we're just going to multiply this out. The first term in each bracket gives us 3p squared. 3p times 1, 3p plus 5p. So that's plus 8p. And then 5 times 1, 5. Okay, this is a quadratic equation. Let's subtract everything from the left-hand side. So we're going to subtract p squared from both sides, and we get 2p squared. We're going to subtract 6p from both sides, and we get 2p. And we're going to subtract 9 from both sides, and we get minus 4. Okay, next up, we're going to divide. Sorry, just checking this out. sorry. Next up, we're going to divide through by 2, and we get p squared plus p minus 2. And now we're going to try and factorize this, and it factorizes quite easily to p plus 2, p minus 1. So p either equals -2 or 1. That's the answer, but I would be tempted to just put those p values into the original expression here and just see what does this thing actually look like, right? If p is -2, our three terms are going to be -1, 1, -1. Those are definitely in geometric progression. We're multiplying by -1 to get from one term to the next. Alternatively, if p is 1, our terms work out to 2, 4, 8, which is also an alternate but definitely legitimate geometric sequence with a common ratio of 2. Okay, as we did previously, if we have two equations, we can solve for two variables rather than just one variable. Remember our formula? Tn equals ar to the n minus 1. What we've got here now is we know that the seventh term is 192, and that means that 192 is actually equal to ar to the 7 minus 1. We know that the second term is 6, right? So 6 is a times r. Okay, I've got two equations here. Here's equation number 2, and here's equation number 1. What I'm now going to do is I'm going to divide them, right? We're going to take the top equation, and we're going to divide it by the bottom one. So in other words, we're going to go number 1 divided by number 2. And what we'll see, 192 divided by 6 gives us 32. When we divide ar to the 6 by ar, the a's divide out and we get r to the 5. And as we said last time, this is kind of an la step, right? Because we only have one variable left. Now what we're going to do is we're going to raise both sides to the power of 1/5, right? Because remember, the power of 1/5, when we apply a power to a power, the exponents will multiply, and I'll just get r to the 1. If I do that on the right-hand side, I must do the same thing on the left-hand side. So I get 32 to the 5th, right? And 32 to the 5th is actually 2. So r is 2. Now what I'm going to do is I'm going to substitute that value for r into this equation over here. Right, now if r is 2, then I get 6 equals 2 times a. And if 6 equals 2 times a, divide both sides by 2, I get a equals 3. Right, and now I'm in a position to write down my first three terms. My first term is a. I'm then going to multiply by r, which is 2. 3 times 2 is 6. And I'm going to multiply by 2 again to get 12. Right, and there's my sequence. Let's try another one. Perhaps you want to pause the video and try one yourself, and try it yourself, and then let it run again. Okay, remember that Tn is ar to the n minus 1. Here we've got T5 is 162. So 162 is ar to the 4. 6 is a times r to the 1. We've got these two equations. Once again, we're going to divide them. 162 divided by 6 is 27. A divided by a, no a's. It's just 1. R to the 4 over r cubed. Right, I'm now going to find the cube root of both sides. That's the same as raising to the power of 1/3. And I get r equals 3. Now I'm going to substitute that value of 3 into this equation over here. This is probably the easier one to use. Right? So if r is 3, I end up with 6 equals 3a. So A must be, if I divide both sides by 3 now, A must be 2, right? And I kind of sort of home and dry, I've got A and I've got R. Let's just check what the question asked us to do. It actually asked us to find T8. T8, remember, is going to be my A value times my R to the power of 8 minus 1. Right, there we go. And we get the number 4,374. That's the 8th term of the sequence that has those two terms, the geometric sequence. And that brings us to the end of this lesson.